Now, before I start, can I have a quick raise of hands? Who of you has ever used a virtual reality headset in some sort of context, be it gaming, a trade fair, a birthday party? Could you raise your hand for me? That would be great. Wow. We've got quite some professionals here today. Okay. Could you keep your hand up if what you did in virtual reality was anywhere aviation or ground handling related? Oh, it's a bit less. It's quite a gap. Okay. So many of you have tried VR at least once, but only very few have done so in our industry, and I'm wondering, why is that the case? So why is the gap that big? And what would it take to close it? And is it even worth the effort? That's what I would like to focus on today for the next 9 minutes. My name is Enzo Skandella. I'm leading the commercial side at Draxon, and we're a German company specializing in virtual reality for ground handling training. Now, before diving a bit deeper into VR, let me set the context. Technology is starting to reshape how ground handling training is delivered across all three training types: theoretical, practical, and on the job. Whereas VR is especially relevant for practical training, as it allows trainees to rehearse procedures and get familiar with GSE equipment before ever touching it. Now, judging by the raise of hands in the room that we just had, I think we still have quite some homework to do here, but VR has actually come its way over the last years. So 5 years ago, VR in aviation, and especially in ground handling, has been really much more of an experiment. So there were a handful of companies in the world that have done experiments, early stage pilots. Now the picture is much more varied. So some of the leading global aviation players and ground handling players are actively using VR across multiple stations, multiple languages, and have integrated virtual reality training into their curriculum. So not just doing it on top, but actually integrating it into day-to-day training operations. So the question has become a bit less of an, does that work? Is that even real? And more of a, where could this work for us? How could a deployment look like? And one of the main enablers of this is actually that the hardware has become much better over the last couple of years. So Adam showed this example with the computer, and so carrying around a computer is very annoying. It's not scalable, but a couple of years ago you would still have to connect the headsets to a computer with cables, and you can imagine that you don't want your trainers to do that, and a lot of stations don't even have the infrastructure for it. But now the devices are at a level where they're completely standalone. So you put on this headset and you have literally 100 training lessons on there. You can start in 2 minutes, and it's just way easier to deploy now. The cost has gone down as well. And so overall, VR has come its way over the last years. Now, where does it actually make sense to use VR? Because VR surely is not the right tool for everything. You're not going to need VR to learn how to fill out a load sheet or to learn how to put up a high-vis vest. But there are certain scenarios where it makes sense to think about, could I put this into virtual reality? Would that make sense? There's a framework for that called the DICE framework, standing for dangerous, impossible to rehearse on demand, counterproductive, and expensive. And if a training scenario meets at least one of these 4 criteria, you could think about potentially putting that into VR. To give an example, dangerous, think about approaching an active engine intake. You can't really do it in real life. You can't really show what happens. What would happen if? In virtual reality, however, you can actually have someone walking up to the engine, and you could see the proximity of it and what would happen. So that's really the beauty. You can show what would happen if, and there's a lot of scenarios. The ramp is a dangerous place where you can't really show these outcomes in real life. Impossible to rehearse on demand. Think about adverse weather conditions. Think about a contamination spill or an emergency. You can't wait for snow to train your people or an accident to train your people. But in VR, you can basically toggle between different scenarios. So you can do so basically everywhere. You can take the headset with you at any time. And yeah, so it's just very flexible. Expensive. in the end, a lot of cost doesn't necessarily come from training with equipment, but from mistakes that happen. And a lot of these mistakes, so I mean, we all know that GSE and aircraft damage are one of the single biggest avoidable cost items in our industry, and a lot of that boils down to operators' inexperience with the equipment. So in VR, you can make these expensive mistakes early on at a near zero marginal cost of repetition. Let me show you how it works in practice. So if you had a bit of an afternoon dip, I hope that you're ready again and awake again. So this was just an example of a couple of the VR lessons. So basically giving you a bit of a picture of where VR is at in 2026. Now, actually, what factors to consider when wanting to deploy VR? There are 5 patterns we are observing across deployments that tend to differentiate deployments that succeed from the ones that stall. Number 1 being a large number of lessons, so a certain curriculum breadth, you could say, because a single well-built module can have its benefits, but if trainees can come back to virtual reality over and over again across the curriculum, I mean, you need the headsets anyways, you need to onboard your trainers anyways, then that just has the most operative benefits. Secondly, one of the most important things is that currently most of the VR trainings out there in the industry, in our industry, are custom developments built for one single operator, one single station. You can't really transfer them across geographies, across the industry. And I'm asking the question of why? Because we have the shared standard, we have the AHM 1110, so why not build upon it to make courses transferable across the industry? Next, scalable hardware, already touched upon that. If it takes IT support or 20 minutes to set up a VR session, it's probably not going to go well. Auditable record keeping, you don't want to introduce another IT system with separate data in some silo, but you would want everything that happens in VR to flow into your record keeping system. And lastly, and most importantly, change management by the training organization. So it's not good enough to just ship some headsets, even they might be good headsets, great courses, but you need to be very close to the actual users. So to the users, the trainees, the trainers, in the end it's these small nudges that really add over time and that make a difference in deployment. Now, this is what a VR curriculum could look like when aligned with AHM 1110. So you can map VR courses to the RMP chapters of the AHM. Quick feedback from the ramp. One statement or one sentence that really stuck with me from one of the station managers we're working with is, my trainees fail in VR so they don't fail next to an aircraft. And to close it off, we're in this industry together. We have the technology. Virtual reality is nothing entirely new, but something that has now matured enough to actually use it and deploy it in an everyday training context. And why not base it on the standard AHM 1110 that we have? And with that, thank you, and giving it away to Claudius.